Welcome to your Relevant Solutions podcast. I'm Rhett Harris, the Parker Business Unit Manager for Relevant Industrial, and today I have two gentlemen from Parker Hannifin with me, Mr. Bob Ty and Mr. Harsh Parekh, and we are really excited to talk to you today about a Parker technology called Phastite. Bob, Harsh, would you gentlemen like to introduce yourselves?
My name is Bob Ty. I'm the Global Business Development Manager, Oil and Gas, Energy with Parker Hannifin. Celebrated 30 years at Parker. Been in the industry almost 30 years. And I'm looking forward to talking about some of our products and solutions today.
Thanks for having us. I'm Harsh Parekh. I'm the Parker Engineering Supervisor in Houston. I've been with Parker for 14 years now, and I look forward to talk to you about Phastite today.
Gentlemen, I really appreciate y'all joining me today. I'm really excited about this. And what we want to talk to you today about is a Parker technology, a fitting technology known as Phastite. Bob, can you give us a little bit of history on Phastite and kind of a brief overview of what it is?
Yeah, sure. Phastite, the best way to think about it is a permanent weldless metal-to-metal seal connection. Okay, so the key there is it's weldless and it's permanent, which means that once you make it up, it's a permanent connection. It's also an alternative to orbital welded tube systems. And we came up with Phastite almost 20 years ago, but we've had several iterations. And I would say the most recent one, probably the last 10 years, we've really dove into a lot of the subsea oil and gas markets, but we play in the upstream, midstream, and the downstream with this Phastite technology.
And Harsh, can you explain a little bit about what it does and how?
So it's a really unique connection. It's a bite type of connection which bites on the tube. Depending on the size of the Phastite, it has rings on the sealing rings. It can be from 3 all the way up to 5 or 6, depending on the size. And it also has a anti-rotation system built into it. So it's unlike anything out there right now. It took us a while to develop this, but it's one of the foolproof designs we have out there.
It is impressive. One of the things that I've seen and being exposed to it from you two gentlemen and whatnot, the simplicity of it and the replicability of being able to do it the same way over and over again, as opposed to relying on the skills of a welder. Not to discredit that, but there's a variability there where I think the engineering behind the tool sort of guarantees, if you will, a consistent makeup every time.
Yeah, we have a few checks and balances when you make up the fitting, and we'll go through one in a bit. But if you follow the steps, if you go through all the steps and check all those inspection points, you'll have a consistent makeup every time.
Yeah, I think that's really 3 key points about Phastite is that it's consistent, safe, and reliable. So in any industry, specifically oil and gas, that's the first thing they look for. How consistent is this makeup? As a new hire can make this up as easily as a 15, 20-year experience technician or engineer, reliable. It's one and done. Once you make it up, that's it. There's nothing else to do to it, right? Consistent, safe, reliable. It's really the 3 key words associated with Phastite.
Right, and I know as an alternative to welding, you don't have to have a hot work permit.
Yeah, there's a lot of, so that's a really good point about orbital welded tube systems, You have all the pre-welding, post-welding processes involved with a hot work permit, non-destructive examination testing, purge gas, welding equipment. You need to have a certified welder, right? Whereas with Phastite, a technician, an engineer, and a welder can put it together without having to go through extensive classes that involves welding, right? So, our class is typically a 2-day class. We'll put you in front of we'll go through the product line, and then it's hands-on for a day and repeat. And then once we're comfortable that you know how to make up the system, then we issue a certificate to the technician, whoever's being trained. And that goes in into the personnel file as, okay, another skill set. So it's a very versatile piece of equipment and connection, but we're really seeing it in a lot of different applications.
Yeah, and to bring to that point, when you weld, if you're making a repair to an existing skid or a tree or something like that, you've got to disconnect all of the electronics, if I'm not mistaken, correct? Whereas with Phastite, that's not an issue. And that brings up or reminds me of a point that you were telling me about at one point, Bob, about going down to Fushan for a customer, which we can't talk specific customer names just so we don't want to violate confidentiality, but this is a large offshore oil drilling outfit.
You know, anytime you apply heat to anything, you're gonna damage it. Like, so heat to electronics, and what Red is talking about is really specific to like a subsea control module base, which is the electronics or the brains of a subsea tree. So when there's welding, they have to take all the electronics off because heat obviously will jeopardize the integrity of electronics. With Phastite, we can go in there and fix the leak, fix the connection, add a line without ever having to take the time to disconnect the electronics. So that's really a huge benefit for our customers, is that time-saving element of not having to remove the electronics, put it back on, and test it. And the Fushan example was a great example of an operator who needed to get a tree pulled up, brought to dock, and typically they clean the tree, drive it to Houston. That's probably a full day's work. And then they have to unwrap it, do a lot of prep before they fix the tree. For this project, we drove right to the dock and we were able to get the tree up and running, our part, in the day, so they could get the tree back in the water, sink it, and start producing oil again. So if think about the cost savings and the value proposition of a well being shut down for 10 days at 100,000 barrels a day, when we can save them that kind of time, there's really, the cost associated is pale comparison to, the benefit of getting a piece of equipment like that up and running.
Sure. Yeah, that's huge. Jumping around a little bit here, but just recently, Brookhaven National Labs had tested a fitting that had been made up for them. He has a demonstration.
Yes, that was a interesting application. They did some testing under cryo conditions, really low temperatures, and they did it all independently without us being over there. To their surprise, which they were not even expecting, but to their surprise, all the fittings passed all the tests that they required. So it was a thorough testing, and now it's published in DOT as an alternative for their application.
So all of the Department of Energy labs have access to that data and that testing information and have the ability to use it. That's Sandia Labs, Los Alamos, Lawrence Livermore.
Yeah, actually, any Department of Energy site will have access to it if they click on the link and it's internal. So from what I understand, if there's a new product or a new application or new release of technology, obviously the DOE community shares it. And so if you're at a DOE site in New Mexico or New York or Nevada or Texas, you can click on this link and see the full detailed test report of this Phastite that we did in vacuum service, which on a 1-inch stainless steel fitting, which typically we have gone into the 15,000 to 20,000 PSI high pressure, high temperature range, where with this test, it was in vacuum service, 10 to the minus 11 cubic centimeters of helium under very cold conditions. So it's quite like harsh status. It's quite a leap from subsea, downstream, subsurface oil and gas to a Department of Energy lab in that kind of application.
Right, but that kind of addresses and talks to the diversity of the technology and the product where it can be used. Speaking of subsea again, Phastite just recently achieved TRL 7 certification, and can you talk a little bit about that or talk to that, what that actually means?
Yeah, so TRL 7 is Technical Readiness Level 7. And it really is a technical evaluation of products that really started with aerospace industries many years ago. And a lot of the different industries have kind of adopted that as the baseline to confirm and validate products or solutions. So when we were putting Phastite subsea on subsea trees, one of our customers, one of the major operators said, well, are you at TRL7? And we said, well, what is your definition of TRL7? And they said that, well, it has to be subsea, working more than 3 years with no major incidents or issues. So this year we reached TRL7 with 4 operators with products in the Gulf of Mexico, off the coast of Brazil, and off the coast of Italy. So for us and for the oil and gas industry, that's quite a milestone to be able to publicly say that we are at TRL7 with Phastite. And we have permission from our customers to say that we can say that. So we have documentation signed up that says, yes, Parker's Phastite is at TRL7 with this field or this tree.
Right. Okay. That's great. But, and again, back to the diversity of the product in the industries where it can be used. I know that there was some high pressure steam lines that we came in and did some work on.
Yeah. So in the Gulf of Mexico, really anywhere where you have refining or petrochem, definitely with refining, you've got coker units, you've got vapor recovery units, high pressure, 100-pound steam or higher. And we had one of our customers had an incident where the asphalt strainer, so to speak, they had some steam lines that were rupturing and leaking. So they gave us a call and we went in there and fixed it with Phastite. And that's almost 3 years ago, coming up Christmas actually, because it was a week before Christmas. I was on site doing that. So yeah, it's a very, like you said, very versatile, upstream, downstream. We don't do too much in the midstream level yet, but subsurface, we're the only product line within Parker that I'm aware of that is subsurface on a land base, on 3 land-based operations, right? Alaska, North Dakota, and South Texas, which is 10,000 feet plus underground. So we're in the bedrock.
Down in extreme pressure, temperature.
High pressure, high temperature, monitoring pressure and temperature on digital equipment.
Right. From my own personal standpoint, last year I went and did a demonstration at a large semiconductor manufacturer over in the Austin area. And they brought in a gentleman who was responsible for all of the chillers in the plant. And once I demonstrated it to him, he said, "You mean I only have to worry about 2 connections, one on each end, because these chillers have lots of tubing run, and typically they're made up tubing, or made up connectors. When they commission it, and invariably there's a leak somewhere, and they've got to trace it out and find it over as much as a couple hundred fittings." And when he saw the simplicity of the tool and makeup, which we'll do here in a few minutes, and the reliability of it, he was immediately that was all he needed to see, that I only had to worry about 2 fittings instead of everything in between. So for me, I think the technology is available and the opportunities are there. As people see it and get more educated about it, they'll come up with places to use it.
Yeah, we have seen that in a couple occasions. So initially it was designed for pressure, for tubing system, for pressure containing systems. Then recently one of our customers started using an electrical application, and now they are using it to measure, like Bob was saying, to measure the temperature and pressure subsurface. So over the time of the Phastite, people have found an application for it, like the Brookhaven National Lab. So it's been, the word has gone around, and with the simplicity of making up the fitting, it's been so widely used in different applications now.
And I'm excited to tell you all I have 5 tools.
Yeah, that's right. You mentioned connections. You mentioned that customer on the semiconductor side with the fittings. That's one of the things with Phastite is, when you receive Phastite, you get this fitting. There's no loose parts, nothing falls apart. There's nothing to unscrew. Okay, this is a 1 inch union, this is a 1/4 inch, so our sizes go from 1/4, 3/8, half, 5/8, 3/4, and 1 inch. So we run a pretty large size of gamut, and the material would be 6316, Inconel, Incaloy, 625, 825, and 2507 Super Duplex. And my point, as Retta mentioned, is you get the fitting as is. So there are no loose parts, nothing falls out of the box, and you get this and it's ready to install. So that's, again, part of the simplicity of having Phastite as a permanent weldless connection.
Is there anything else you gentlemen would like to add at this moment, or you want to make up a couple fittings maybe?
I think we'll go into the demo. I think once you look at the demo, the actual makeup, it will show you how easy it is to make up a fitting. And well, let's jump into it.
Yeah, let's do it. Now we're going to make up a couple of fittings. We're going to use 1/2 inch tube union, 3/8 tube union, and some of the components that are common to the different tools, which we'll talk to in just a minute. This is the tube marker. These are the inserts that will go into the tool, and that's one of your safety checks, is making sure you've got the right color code for the particular size. This is the tool. This is the controller, which will actuate the tool. And this is your power supply. It's pretty simple, so let's get to it.
Let's start with the 3/8. So I'm going to grab the 2 tubing and the union. The first check is the safety check is we have to make the tube markers. So you take the tube marker, insert the tubing into the tube marker, push it, make sure it's bottomed out, and just rotate it a few times. What it does, it creates a 2 line on the tubing, and we'll do the same thing on the other tube. There's no really any special things required on the tubing. You have to just make sure the tubing doesn't have any scratches, which can be a potential leak point. But if the tubings are deburred, if it's clean inside and outside, that should do it.
Yeah, and all the tube markers will have the size laser marked on the end. So he's doing 3/8, so you'll see this as Parker 3/8 tube marker.
So now these 2 tubings, which we're going to make up, has 2 lines on each side. And then the next step is we take the inserts. So depending on the size, all these inserts are color coded. So for 3/8, it's a black color, and 1/2 inch, it's a red, and so on. So we'll just drop the inserts into the tool, and it snaps in there. So the inserts doesn't move during the makeup or doesn't fall out. Well, the next step is we take the fitting, make sure the tubing goes inside the fitting such that you do not see any lines. So when you insert the tubing into the fitting, you should not be able to see any of those two lines that we marked up using the tube marker. And after that, we'll insert the fitting into the tool, and the tool has spring-loaded retaining pins where it holds the tubing together, so the tubing doesn't move, or tubes doesn't move during the makeup. So just make sure, last time, make sure your tubes are bottomed out all the way into the fitting. You don't see any of the lines, and that's it. Now you're ready to make up a fitting.
Yeah, and up to this point, a technician that typically will work with tubing and other fittings will do the same procedure. Cut, deburr, clean the tubing, insert tubing into the fitting body, and make sure it bottoms out. That's regardless if it's Phastite or anything they have. So that procedure doesn't change. And then when we make up Phastite, then the tool and how it makes up it changes. But the basic fundamentals of cut, mark, tubing, insert, bottom out doesn't change.
So now we take the controller, and you'll see there's a cycle count on there. That's to keep track of the number of fittings or number of cycles on the tool itself, and then the recommended return for service is at every 3,000 cycles. So that helps keep track of that. The other thing that you can do is this one they're all password coded so that you can assign a password to an individual to know who's making them up and keep track of what fittings and so on. But it's just as simple as this, and you're going to be watching that.
So one thing to remember when you're making up the fitting, because this is a smart controller, the tool will, the power source will stop by itself. After you make up, you just pull the tubing out, or the fitting out, and you should be able to see only one line after the makeup.
On each side of the fitting.
On each side of the fitting.
That's it. It's that simple.
The time it took Red to actuate that tool, probably less than 5 minutes, okay? So equate that to how long that takes for you to prep a weld, which is an hour or more, depending on the accessibility of the equipment and how easily it is for them to get that over the welder in there. So, and the cycle count, he said, so on this controller it says 40. So one cycle is one complete makeup, okay?
All right, so let's make up a 1/2 inch. It's going to look the same way.
Should we get a volunteer from the audience?
Yes. This is Shelby Rojas, our product marketing manager for Relevant Industrial. And Shelby has seen what we just did. And we are now going to let Shelby make one up with our guidance, of course. But Shelby, let's have at it. We're going to make up a 1/2 inch tube union.
Okay. So this piece, right?
That's the fitting. So the first thing we need to do is mark the tubing.
Okay.
So this is your 1/2 inch fitting or tube marker. You insert it all the way in. It is spring loaded, so you want to push it in and make sure that it and then spin the marker. There you go. There we go. So we got 2 marks. No. Just now we're going to take the other tube. Do the same thing. Okay. Make sure you've got 2 marks.
I've got 2 marks.
All right. Now, we need our 1/2 inch, which are red color code, inserts. There you go. Make sure it locks in. All right. Now, we pick up our fitting. Make sure you're using the side that's got the marks on it.
Mm-hmm.
And your other tube. You should not see any marks.
Right.
Safety check. No marks. Okay.
Just put it like that.
Yes, ma'am. Push it down, it'll lock in. Okay. Now, on the pump, we've got terminate and actuate. So we're going to turn it over to actuate. That's ready to go. Pick up your controller and press start. You see it shoulder up. That's good. All right. Terminate. Let's the pressure off. Okay. Take it out. Now you should see 1 line on each side.
There's 1 line on each side.
So yeah, an example of how this has been used and in partnership with Relevant.
So we've had several successful installations in the Gulf of Mexico with Phastite. One I will talk about is a grassroots facility near Gregory, Texas. It's a petrochem facility. Grassroots meaning that it's a brand new plant, brand new facility. And they had an opportunity to use Phastite on helium carrier gas lines that feeds into the analyzer. So they wanted to get away from, there were some welds that they didn't like, and so they gave us a call, and Relevant and I worked together with the site supervisor, the site contractor, to go in there. We did a walkthrough, figured out where the fittings, where the Phastite connections were going to be, and then we went in there, and I think we put about 8 to 10 Phastite connections on this petrochem grassroots facility located in Gregory, Texas, in the Portland, Gregory, Texas area. What was unique about this was that it was really this operator's first Phastite installation on a downstream asset. as well as it was really our exposure to one of the contractors that was working for the operator to see the product line. And really as a result of that installation, the contractor now has bought a tool for another job that's offshore on a FLNG project, and that's been pretty successful. So the contractor saw the value of having Phastite, the time element, as you see, when Shelby, myself, and Harsh put it together, I mean, it was less than 5 minutes, right? So it will probably take a little longer. People prep the tubing, and you got all kinds of, on a job site, there are things that you can't control, but once that tubing is ready, that's how long it takes us to make up the connection. So that was a really good case on a grassroots greenfield project. And then we had several more in Port Arthur with another operator on a refining side that has a lot of these connections on the coker and high pressure steam units as well.
Great. So gentlemen, thank you both for being on the podcast today. I appreciate it. And those of you listening, thank you. And we'll see you next time on the Relevant Solutions podcast.
Thank you for having us.
Thank you.